Good afternoon, everybody. Up to now, we have to be seen the chapter 5. In that case, we have to be seen the all of the thing which should be related with the regulated power supply. See, why we just within 2 or 3 minutes we have just introduced the something related to the regulated power supply, unregulated power supply. See, day to day life we have to be need of the many times power supply. That is with respect to the DC power supply. See, we have bulk amount of AC available, but for the devices such as electronic devices used in a laboratory as well as small applications such as battery, we have to be need of the DC power supply. So that's why we have to be convert the AC voltage into the DC, right? For this, this should be required for the purpose of the power unregulated power supply. Okay, in that unregulated power supply, we have seen that many things such as start up with the rectifier configuration, that is half wave, full wave, center tap, that type of the configuration used for the purpose of rectification. Okay, rectification indicate that it is the device which should convert the AC voltage into the pulsating DC voltage, right? So for the purpose of unregulated power supply, we have need of the regulated power supply, right? So for that purposes, you have to be remove the ripple indicate that unwanted component. For that unwanted component that should be removed, for that purposes we have to be use the method such as filtering component. Okay, so filtering component are used for the purpose of the filtering the unwanted component. After all, we have to be seen the regulator, that is whatever the power coming from your rectification as well as filter, means output of rectification which should be sent towards the filter, whatever the output coming from filter, that should be changing, right? So to give the non-changing, that is a regulated output, we have to use the regulator IC. There are two type of regulator IC, that is a 78XX and 79XX. 78XX indicate that positive voltage regulator, 7XX indicate that negative voltage regulator. Okay, that are used according to our use. Okay, these are we have things we have to be studied. After all, we have to be seen one of the problem, that is design of unregulated power supply with respect to the capacitor type of filter. Please tell me which I have given already one of the problem. कुणी कुणी सॉल्व केलाय त्यांनी सांगा मला. प्लीज टेल मी. सॉल्व केलाय तुम्ही? वेद पाठक सॉल्व केलाय का? अमित जाधव केलाय? प्रॉब्लेम सॉल्व केलाय? चालेल, पूर्ण सॉल्व केला मला व्हॉट्सअप करा. मी आन्सर बरोबर का सांगितलं. कुणी केला आणखीन? विनायक गोरे, अमित जाधव केलाय का तुम्ही प्रॉब्लेम काल दिलेला सॉल्व? ऍक्च्युली ज्यावेळेस तुमची ऑनलाईन एक्झाम असेल त्यावेळेस नसणार आहे, लक्षात घ्या, प्रॉब्लेम नसणार आहेत. परंतु तुमच्या यू आर वन ऑफ द इंजिनियर, राईट? इंजिनियरला अनालिसिस हा पार्ट असतोच, लक्षात घ्या. ओके, नसेल तर सॉल्व करून मला व्हॉट्सअप करा. ओके, सी up to this last lecture we have seen the chapter number 5. Today at 5:30 I am given the test related to the chapter 5. Okay, now we have to be see the one of the important chapter, that is feedback amplifier. Okay, now see what do you mean by feedback, what do you mean by feedback amplifier, that we have to be seen here. See, one of the important thing with respect to this chapter is that feedback amplifier indicate that we have to be use the concept of feedback in this case. Now what do you mean by feedback? We know that, see, according to with respect to this diagram, see, this is the diagram which shows that the feedback. Before seeing the feedback, I have given the something related to the feedback amplifier, right? See, why we need of the feedback and why, what do you mean by amplifier? See, I am discussed separately. See, amplifier indicate that it is the device which should gives the whatever input applied across it, that should be enhancing stage, means whatever the value applied across your input, that should be increases with respect to your output of your amplifier. So amplifier is the device which should be enhances whatever input applied across it without changing the performance of the circuit. Okay, these are the thing with respect to your amplifier, right? So feedback means what? See, feedback indicate that some part of output is again applied to the input. This is nothing but a feedback. Okay, right? So I'm telling you again the concept of feedback and amplifier separately. Okay, feedback indicate that some part of output is again applied to the input. It is called as feedback. Okay, amplifier indicate that it is the device which should amplify whatever input applied across it. Amplifier indicate that enhancing or increasing the value of whatever input applied across it. Okay, this is the thing related to the feedback and the amplifier. Okay, now we have seen the what is feedback amplifier, right? So feedback amplifier indicate that for that, seeing the feedback amplifier concept, we have seen the things that is a feedback first. Okay, so in this case feedback is used. See, above figure shows that feedback is used. Okay, feedback means what? Here what? See, we have applying the any input, right? So this, consider as this is any devices. Okay, any device we have applied the input, its output is coming. Okay, the part of output is again applied to the input. Okay, this is called as feedback. So feedback is nothing any other. So when we have to be applying the input, it got the sum of the output, some part of output. See, there is not all of the output is applied to the input, some part of output is again applied to the input. This is called as feedback. Okay, now this is nothing but your feedback. Okay, so what will be the limitation, what will be the advantages of that, we have to be discussing. Okay, in this type of amplifier, see, in this type of the amplifier, feedback is the limitation which calculate the sum of the pair given to the following amplifier. Okay, now see, whatever the sum or output coming, see, we have provided the input, we have got the output. Okay, this is the thing with respect to any of the circuit. But in some amplifier indicate that when we have required the more and more enhancing the signal, right? More and more enhancing signal. So what they have to do, some part of output is again applied to the input. Okay, so what happened, the accordingly there are basically two types of the feedback. Okay, one is positive feedback and another is negative feedback. See, whatever the, consider input applied here, it is a sine wave. Consider input applied, it is a sine wave. Okay, sine wave is the input applied, whatever the output coming, that also sine wave. Consider sine wave. Okay, input sine wave, output sound sine wave. Okay, that again this sound sine wave is applied to the input. Okay, now this type of feedback is called as positive feedback. Now how we have defined the positive feedback? See, when, see, definition of positive feedback, when input and output which should be applied to the input that have 0-degree phase shift, means consider the example, we have applied the sine wave, whatever the output coming, that is a sine wave. Okay, means they have same phase. See, only change is that if we apply the strength of signal of 1 volt, it got the signal of 5 volt, right? But without changing the shape. Means sine wave is applied, as sine wave is coming across your output. Okay, that again sine wave is applied to the input, right? So whatever the signal across your input, whatever signal across your output, that doesn't have any sign change. Okay, why it is not changed? Because input has sine wave, output have sine wave. So there should be phase shift between output and input. It is a 0. Why 0? Because we have applied the sine wave, we have got also sine wave, and again sine wave is applied to the input. So it indicates that there should be 0 phase difference between your output and input. In that case, that is called as positive type of the feedback. See, positive type of feedback indicate that we have applied the sine wave, we got also sine wave, again that sine wave is applied again to the input. In that case, there should not be any change with respect to your output and input. So that's why it is called as positive feedback or 0 phase shift across output and input. Okay, so these are the things with respect to the positive feedback. Now see, negative feedback means what? See, if we have applied the sine wave, we got the cos wave. See, we have applied the sine wave, we got the cos wave with amplifier form. Okay, again that cos wave is again applied to the input. See, cos wave is again applied to the input. What indicate that we have applied the sine wave, we have got the cos wave, so it indicates that 180-degree phase shift. Okay, so if there should be 180-degree phase shift between output coming from your amplifier, that should be provided to the input. Means if there is a phase shift between output and input is equal to the 180-degree, then that type of feedback is called as negative feedback, right? So we have discussing the two type of feedback with respect to your amplifier. Now I'm tell you three things with respect to feedback. Feedback indicate that some part of output is again applied to the input. This is called as feedback. Okay, we have defined another term with respect to the feedback, that is positive feedback, and another is negative feedback. See, when some part of output again applied to the input, right? So in that means there should not be any phase shift between output and input. We take out the example of we have applied the input as a sine wave, we have got the output as a sine wave. In that case, there should be 0-degree phase shift. In that case, that type of the feedback is called as positive type of the feedback. Okay. Then we have to discuss another term, that is a negative type of the feedback. So negative type of feedback, what it indicate, that if we apply the signal as the input sine wave, we got the cos wave, right? So again that cos wave is applied to the input, right? So phase shift between input and output, that is a 180-degree. So when we have to be applying the input and output with respect to us, then again output is applied to the input, it have phase shift of 180-degree. In that type of the feedback is called as negative type of the feedback. Okay, negative feedback means there should be phase shift between input and output have 180-degree. That is called as negative type of the feedback. So I'm take out the example of the positive feedback and negative feedback. See, positive feedback usually in case of oscillator. See, example means in case of oscillator devices, we have to use the positive feedback. Another important thing with respect to positive feedback is that when we have to use the positive feedback, it increases the gain of the amplifier, right? So why we need of the amplifier? Because whatever thing applied across it, it should be enhances, right? This thing should be happen with respect to the oscillator. Okay, now we have discussed the another thing, that is example of the negative feedback. See, negative feedback, see, one of the important thing with respect to negative feedback is that when we have to use the negative feedback, it reduces the gain of your amplifier, right? So what it does, when we have to use the negative feedback, it reduces the gain of your amplifier, right? So this is the thing with respect to negative feedback. It also, see, it also we have to be use this type of the feedback in case of your amplifier. See, I'm again repeat it. See, positive feedback is used for the purpose of the oscillator, right? When we have to use the positive feedback, in that case, whatever the gain of your amplifier, that is increases, right? So we have to be design the amplifier only for the purpose of increasing the gain of your whatever the input applied. Okay, but this is means positive feedback means if we have to be use the positive feedback in case of your amplifier, it increases the gain, right? So this is the thing with respect to the amplifier, but positive feedback is not used at all in an amplifier, right? It should be used in case of your oscillator. The output of oscillator is sine wave, right? So see, why the negative feedback usually in case of your amplifier? I'm telling you. See, one of the reason behind it is that if we have to be use the see, we have discussed the two things, that is we use of positive feedback, use of negative feedback. See, when we have to be use the positive feedback in case of your amplifier, what is the effect of it? When we have to be use the positive feedback in case of your amplifier, it enhances the gain of the amplifier, right? Positive thing, this is the positive, it enhances the whatever the output coming across it. Okay, but what happened, it enhances the output, but it unstable, means whatever the output coming, that should be changing, right? So this is not acceptable. Means you know about during old time, जुन्या काही ज्यावेळेस आपण म्हणजे एक 15-20 वर्षापूर्वी ज्यावेळेस तुम्ही पाहायचं की ज्यावेळेस एखाद्या प्रोग्राम मध्ये जर माईक विथ अम्प्लिफायर यूज केलेला असतो, बरोबर, तिथं बोलत असतील काहीतरी काय स्कर असा आवाज किंवा कर्कश असा आवाज कधी कधी जनरेट होतो. त्याचं रिझन होतं त्या केसच्या अम्प्लिफायर मध्ये आपण पॉझिटिव्ह फीडबॅक यूज करत होतो. त्याचे देर आर सो मेनी डिसऑर्डरेशन विथ रिस्पेक्ट टू दॅट पॉझिटिव्ह फीडबॅक, बिकॉज व्हॉट एव्हर द सिग्नल कमिंग दॅट शुड नॉट बी स्टॅबिलाइज. ओके, that is the thing with respect to us. Did you get him, voice? Please tell me.
Yes, sir.
Okay. So this is the thing with respect to the positive as well as negative feedback. See, I'm not telling related to the negative feedback. See, when we have to be use the negative feedback, see, when we have to be use the negative feedback, it reduces the gain of your amplifier. Gain reduces means why we have designed the amplifier? Because we have to be designed the amplifier only for the purpose of enhancing the gain of your enhancing the gain whatever input applied across it. Okay, but when we have to be use the negative feedback with respect to your amplifier, in that case it reduces the gain. Why we have to be do the same thing? See, we need of the enhancing gain. Okay, for that purposes we have to be use the amplifier. Okay, but when we have to be use the amplifier, in that we have using the negative feedback. One of the important thing with respect to negative feedback is that when we have to be use the negative feedback, it reduces the gain, right? We need of the enhancing the gain, but when we have to be use the negative feedback, it reduces the gain. Yet also we have to be use the negative feedback in case of amplifier. See, reason behind it is that when we have to be use the positive feedback, right? When we have to be use the positive feedback, it increases the gain. But what happened due to that? It unstabilized means whatever the output coming, that should be changing, right? This is not acceptable. Okay, because whatever you are telling, that should be you don't got, that should be changing. Okay, but when we have to be use the negative feedback, it somewhat gain should be reduces, but whatever the output coming, that should be stable, that should not be changes with respect to time. There should not be any noise should be added with respect to your output of your amplifier. That's why we have to be prefer the negative feedback in case of your amplifier. Okay, we have discussed the three things, that is feedback, concept of feedback, concept of negative feedback, concept of positive feedback, why the positive feedback and why the negative feedback is and where it is used. That should we have discussed. Did you understand this thing? Please tell me. Within a one two sentences, I'm repeat the same thing again. See, feedback indicate that some part of output is again applied to the input. This is nothing but a feedback. Okay, then we have discussed the positive type of feedback. Positive type of feedback indicate that some part of output is again applied to the input, but in that case phase shift between input and output which is equal to 0, that is called as positive feedback. Okay, so phase shift between input and output is equal to 0, that feedback is called as positive type of feedback. When we have to be use the phase shift between your output and input equal to 180 degree, then that type of the feedback is called as negative type of feedback. Positive type of feedback usually in case of your oscillator, negative type of the feedback usually in case of your amplifier. Okay, now tell me, did you understand this slide?
Yes, sir.
Okay. Now, feedback amplifier is the device that is based on the principle of feedback. We know that feedback amplifier indicate that it should be based on the feedback. Why? Because in case of feedback amplifier, we have to use the feedback. Feedback indicate that some part of the output is again applied to the input. Some part we doesn't apply all of the things of the output to the input, right? So feedback amplifier, we have to be use the concept of feedback. Some part of output is again applied to the input. Okay, we know that the definition of the feedback, that is some part of output is again applied to the input. This is nothing but a feedback. Okay, now we have discussed is the types of feedback. We have generally already discussed this term, but through the diagram we have discussed is the particular types of the feedback. Okay, now see, we know that feedback indicate that part of output is again applied to the input. Okay, feedback indicate that part of output is again applied to the input. Part of output indicate that it is the energy, some of the energy. Okay, some part of output energy is again fed to the input. This is nothing but a feedback. Okay, so how it should be corrected means how the means see how we have to be apply the input. Whatever the output coming, that should be applied to the input. According to it, there are two types, that is positive and negative feedback. See, I have given the example of it. See, this is the diagram. This is the diagram. See, in this diagram, we have applied the input as a sine wave signal. See, sine wave signal as apply as a input. Okay, so whatever the output coming across this is a basically a symbol of amplifier. Okay, we have applied the input to the amplifier as a sine wave. Whatever the output coming across it is also the sine wave. See, whatever the input applied across your positive feedback, that is a sine wave. Whatever the output coming, that also sine wave. See here, means input applied is sine wave, output applied, that means whatever the output coming across your output, that is also the sine wave, means feedback. See, input, this is nothing but output again applied to the input, this is called as feedback. Okay, input and output that are in phase indicate that there should be phase shift between input and output 0 degree. Okay, 0 degree indicate that both are same. So if input and output have 0 degree phase shift, then that feedback is called as positive type of the feedback. Okay, we are discussing the negative type of the feedback. Okay, in case of negative feedback, if we have to be apply the sine wave as the input signal, see, sine wave as the input signal. So after all processing of the amplifier, see, this is the symbol of amplifier. Okay, in that symbol of amplifier, whatever the signal applied across, it should be processed. After all processing of this signal, we got the output. Okay, that output is again applied to the input. Okay, so consider input as a sine wave, whatever the output coming, it is a cos wave, right? So sine wave and cos wave have 180 degree phase shift, right? So when phase shift between input signal and output signal, which is equal to 180 degree, then that type of the signal is called as negative feedback. Okay, that is called as negative feedback. Okay, again I'm repeating within one sentence, what do you mean by positive, what do you mean by negative. So positive feedback indicate that if the phase shift between input and output which is equal to 0 degree, then that type of feedback is called as positive. When the phase shift between input and output which is equal to 180 degree, then that type of the feedback is called as negative type of the feedback, right? We know that the example of positive feedback usually in case of example oscillator, negative feedback usually in case of your amplifier. Okay, this is the more description related to the positive and negative feedback. Okay, the positive feedback can be defined as when the feedback, we know that how the positive feedback should be differentiated from the negative feedback. See, when the input, whatever the input applied, right, whatever the input applied, when we have applied the input to the amplifier, we got the output. If the phase shift between input and output which is equal to 0 or 360, I'm again tell you 0 degree or 360 degree, both are same term. Okay, in that case, whatever the input and whatever the output, that should be no phase shift between us. So that's why that type of feedback is called as positive type of the feedback, or it is also called as direct type of the feedback. Okay, so because of positive feedback generate unnecessary distortion. See, when we see why we see the reason behind it is why we have not using the positive feedback in case of your amplifier. The reason behind it is when we have to be use the positive feedback in case of your amplifier, it generates the unnecessary distortion. Distortion indicate that unwanted signal must be added with it. Okay, so that's why noise is added with. So performance of the circuit should be changes. Okay, that's why performance of the circuit changes indicate that if we have to be use the uh, amplifier for audio things, means when we are talking on certain things. Okay, in that in a middle session noise is added, it indicate that sound of any type of such as krr or voice breaking sound. Okay, that's why what happened, whatever the output or outcome coming with respect to us, that should be changing, right? This is not acceptable. Okay, that's why we doesn't use the positive type of feedback in case of your amplifier. Okay, uh, see, but in case of your oscillator, see, in case of your oscillator, we have to be use the positive type of feedback. Why it is used? Because in case of positive type of feedback, whatever the original signal power applied, that only enhancing, that's why we, in case of your oscillator, that should be needed, only that should be needed. No need of the audio signal. That's why in case of oscillator, whatever the signal applied, that should be enhancing. That's why we have to be use the positive feedback in case of your oscillator. Okay, the negative feedback can be defined as, we know that how we have to be define the negative feedback. See, negative feedback indicate that whatever the energy which should be coming across your output, right? Whatever the energy coming with respect to your output, if it have, see, whatever the input applied, consider as we know that sine wave is applied, we got the cos wave. right? So exactly opposite, input and output is exactly opposite. So it again applied to the input. What it indicate that it should causes the whatever the means plus, see, plus 10, whatever the output coming is a -5. Okay, consider -5. Then it again apply to the input, it indicate that 10 minus 5, so it is a 5. So due to that, it indicate that when we have to use the negative feedback, it reduces the gain of your amplifier. Okay, so due to that, in case of your amplifier, if it reduces the sum of the gain, this is not problem because it reduces the gain, but it stabilizes the gain. Stabilizes means it does not changes with respect to time. Okay, that's why negative feedback used in case of your amplifier. Okay, did you understand the concept of positive and negative feedback? Please tell me.
Yes, sir.
Okay. Feedback amplifier topology. Now, what do you mean by topology? That we have to be seen first. See, when we have to be seen any of the things such as amplifier or the feedback, right? We know that there are different feedback. Also have two types, that is positive and negative feedback. Same way, when we have to be use the amplifier, right? When we have to be use the feedback amplifier, it have also different type of the amplifier. Okay, topology indicate that different types of the feedback amplifier. Okay, and how it is used means how the feedback should be used. See, topology indicate that it is basically a feedback amplifier, but feedback amplifier, how the feedback means some part of output is again applied, how it is applied, that is in a series, that is in a parallel, that is applied as a voltage, that is applied as a current. Accordingly, there are four type of the amplifier, right? Means when it should be applied to the input, right, as a voltage, then it is called as voltage amplifier. When it is applied part of output again input to the as a current, then it is called as current amplifier, right? So voltage, current, and it should be applied to the in series, then voltage series amplifier. If it is connected in a parallel, then it should be called as parallel and shunt, that are both same, so it should be called as shunt amplifier, right? So according to it should be connected to the input. Accordingly, it have different type of the feedback topology. Okay, there are four basic amplifier topology for the connecting the feedback signal. Okay, both the current as well as voltage can be feedback towards the input in series, otherwise in the parallel. Okay, so see, normally when we have discussing the topology, two things must be coming, one is voltage, other is current, right? And how it connected, either it is a series and either it is a parallel. Okay, that's why accordingly it must have words such as voltage, current, series and shunt. That are the four words which should be coming with respect to the that amplifier topology. Why it is? Because I am discussed with respect to is that when we have seen the amplifier topology, in that case it should be with respect to how it connected as a voltage, as a current, it should be connected in a series, it should be connected in a parallel. Accordingly, these words are added with respect to this topology. Okay, types of the negative feedback. See, we know that why we have not studied the positive feedback here. Please tell me. For that purposes, I have given you the one hint. Please see the name of that this chapter. Accordingly, it shows that 1 minute. Please give me. Why we have to be only study the negative feedback here more detail, not see the positive feedback more detail. Please tell me. Tell me the chapter name.
Because of amplifier, it will
Right.
bring negative feedback.
Correct answer. Because we doesn't discuss this with respect to the oscillator, we have more discusses with respect to the amplifier. We know that in case of your amplifier, we have to be use the negative feedback. Negative feedback indicate that whatever the type of it. Okay, that's why we have to be seen the detail of the negative feedback. Okay, because we know that when we have to be use the two type of feedback, that is positive as well as negative, we know that the performance when we have to use the positive feedback, when we have to use the positive feedback, it enhances the gain, no problem. But whatever the gain coming, that should be fluctuate or that should be unstable. This is not acceptable. Okay, so we doesn't see it. So we have to be use the another type of feedback, that is negative type of the feedback, which reduces the gain. It should be acceptable. See, reduction of the gain with respect to amplifier, this is not acceptable at all. But if it is somewhat reduced, but it stabilized now, that's why we have to be prefer the negative feedback in case of your amplifier. Okay, now we have to be seen the types of negative feedback. There are actually whatever term I am already told you, basically there are only four term: voltage, current, shunt, and series. Only that term are added with respect to this type of the configuration, no any other thing. Why? Because whatever the output coming, that should be connected as a voltage or as a current. Either it should be connected to the input as a parallel, that is shunt, or either it is connected to the series. Okay, that's why whatever term we have to be discussed here, that should be related to it only. Okay, we're discussing the voltage series feedback. So what it indicates, that whatever the output coming, see, whatever the output coming from your amplifier, that is a voltage, right? Voltage, its name indicate that voltage series feedback indicate that whatever the, see, we have applied the input to the amplifier, whatever the output coming across your amplifier, that is a voltage initially in this voltage series feedback. Okay, that voltage is applied to the input in a series, right? If the voltage of the amplifier which should be connected with respect to input in a series, then that type of feedback is called as voltage series type of the feedback. Did you understand what do you mean by voltage series feedback? I'm again repeat, its name indicate that voltage series feedback. We know that feedback indicate that it should be related to the output. Okay, so in case of voltage series feedback, whatever the output, see, that whatever the output, that should be voltage in this case, right? That whatever the output coming from your amplifier, that is a voltage, that output is again applied to the input in a series, right? That's why it is called as voltage series type of the feedback. Okay, so in this type, a part of output voltage feedback in the series with the input signal. See, they have defined it, but its statement voltage series feedback, it defines that how the particular thing connected with respect to your input, right? So voltage series feedback should connect the whatever the output coming, that is a voltage, that should be connected to the input in a series. That's why it is called as voltage series type of the feedback. So we have seen the whatever the things when we have to be use the voltage series feedback. Okay, when we have to be use the voltage series type of feedback, it resulting into the overall gain of your amplifier, that should be reduced, right? Means when we have to be use the voltage series type of feedback, in that whatever the gain coming with respect to your output, that should be reduces. This thing happen when we have to be use the voltage series type of the feedback. Okay, and another thing with respect to coming across this type of feedback is that it also reduces the output impedance. And right, output impedance indicate that, see, some devices what happen, whatever the impedance coming with respect to device, that should be, this means whatever the device connected across it, it should be less or more. But when we have to base the voltage series feedback, in that effect of it is that whatever the output impedance coming with respect to this type of the feedback, that should be reduced. Okay, and due to voltage series feedback, there should be increase in the input impedance, right? So where it is used, see, when it should be used where the see, this type of the amplifier used for the purpose of the where the more impedance which should be coming with respect to the device. Okay, so what it indicate that ज्यावेळेस आपल्याला पहा व्होल्टेज सिरीज फीडबॅक यूज करायचा असतो, त्यावेळेस काय याचा आउटपुट आहे पहा, इट रिड्युसेस द आउटपुट इम्पिडन्स. याचा अर्थ काय आहे की तुमचा अँप्लिफायर कशाला कनेक्ट करायचा असतो, नॉर्मली स्पीकरला कनेक्ट करत असतो, राईट? स्पीकर और साऊंड, लक्षात घ्या. त्याच्याला जर कनेक्ट करायचं असेल आपल्याला, तर आपण काय करणार, त्याचा इम्पिडन्स कमी असायला पाहिजे, लक्षात घ्या, कमी असायला पाहिजे. जर मी व्होल्टेज सिरीज यूज केलं तर त्याचं काय इंडिकेट करतं, आउटपुट इम्पिडन्स कमी आहे, लक्षात घ्या. म्हणजे इन केस ऑफ नॉर्मल पब्लिक ऍड्रेस सिस्टीम it should be used. Okay, and any of the public address system, it indicate that mic and the amplifier, it is also called as PA system, public address system. So in that system, we must need of the input impedance more and the output impedance minimum. Why? Because any of the device, if the output impedance less, indicate that any of the uh, sound or speaker connected across it means amplifier, and if it have input impedance more, if what it indicate that if noise is not added with respect to it. Why noise is not added? Because any of the devices, if it have high input impedance, indicate that any noise is not connected across it because of more input impedance. Okay, now we have seen the another, that is a voltation type of the feedback. Now voltation type of feedback, what it indicate that in this type of the feedback, whatever the output, see whatever the output coming across your amplifier, that is a voltage. Okay, whatever the output coming from your amplifier, that is a voltage. It should be connected with respect to input in a shunt. In a shunt indicate that parallelly connected to the input. That's why it should be called as voltation type of the feedback. So voltation type of feedback indicate that output coming across your amplifier, that is a voltage. That voltage is connected to the input of your amplifier, that in a parallel. That's why it is called as voltation type of the feedback. Okay, so the voltation feedback provides the stabilized overall gain. See, sometimes what happen, due to some reason, whatever the gain of your amplifier, that should be fluctuating, that it changes with respect to time. See why that happen? Because see, we know that normally amplifier uses the semiconductor devices. One of the important thing happen with respect to semiconductor is that as the temperature increases, its performance should be changes. Why? Because it is related to the semiconductor devices now, because performance of semiconductor changes with respect to the temperature. Okay, so in this case, what we have to see, the voltation feedback provides the stabilizer again, right? So if the things are changes, nature thing means temperature is changing, also that should not be impact on voltation type of the feedback. Okay, so why it is not changes? Because voltation feedback stabilize the overall gain, it doesn't changes the gain. That's why it should be used, and decreases both input and output resistance, indicate that in this case impedance, right? When we have to use the voltation type of the feedback, it reduces the both things, that is the input as well as output resistance or the impedance. Okay, then we have seen the current series type of feedback. So current series indicate that whatever the, see, we have applied the input to the amplifier, then we got the output. That output is nothing but a one of the current. Okay, that current is again applied to the input in a series. Okay, in series with respect to your input, right? In that case, this is called as current series type of the feedback. So what it indicate that, see, output of your amplifier, it is a current, right? Output of your amplifier, it is a current, and that current is again applied to the input with respect to in series. That's why it is called as current series type of the feedback. Okay, so current series type of the feedback, current series type of the feedback, usually in case of your following application I'm telling you related to it. So in current series feedback, voltage is developed which is proportional to the output current. Okay, so see, basically current series feedback is not only the whatever the output coming, this is not a directly current. Okay, whatever the output coming with respect to current series type of feedback, that is basically voltage, right? Basically it is a voltage. That voltage is again converted as a proportionally current. Okay, this is also called as, we know that due to that means whatever the output coming across your current series feedback, that is a voltage, we have to be convert that voltage into the current. This will be happen in this case, current series type of the feedback. Okay, so in this case, even though it is a voltage that's subtracted from the input voltage, right? See, whatever the output, we know that that should be voltage coming across current series type of feedback, that is basically voltage, right? It should be converted as a current, and then it should be subtracted from your voltage, again it should be converted as a voltage. So in this case, current series feedback, what we have to do, whatever the input coming, see, whatever the input coming, that is a voltage, whatever the output coming across your current series feedback, that is also the current. But see, when it should be output of current series feedback, it is a current, it should not be possible to subtract with respect to input, right? That's why it should be changes with respect to current, but it is a basically voltage. Okay, means input is a voltage, output means input of your amplifier, it is a voltage, output of your amplifier is also voltage, not a current, proportionally voltage, right? Why not it is a current? Because if it is converted as a current, it does not subtracted by your input. Okay, that's why it is a current in accordance with the level of the current. Okay, because of this series connection at the input and output, the input and output resistance get increased. See, if the connection between both, that is a input and output, it should be connected with respect to your series. Why it is connected in a series? Because see, current should be measured always in a series. Okay, always measured in a series, and it connected across it also series. So both things are in series. That's why it causes whatever the input and output impedance coming with respect to current series type of feedback, that should be enhancing, that is increasing, right? This type of amplifier is called as transconductance type of the amplifier, right? Transconductance indicate that it is opposite to the of the resistance. Okay, current shunt feedback, right? So see, we are discussing the current shunt type of the feedback, right? Current shunt feedback amplifier indicate that whatever the output coming across your amplifier, that is a current. Okay, that current coming across it, it should be applied to the input is in a shunt indicate that parallelly to the input. That's why it is called as current shunt type of the feedback, right? I'm again explaining you current shunt feedback, what it does. Current shunt feedback indicate that whatever the output coming across your amplifier, that is a current, and that current is again applied to the input, that is nothing but a current shunt type of the feedback, right? Actually this type of the feedback is called as derived shunt feedback. Okay, the connection at the input reduces the input resistance, right? In this thing, what happened when we have to be use this type of feedback in case of your uh, amplifier? So it is applied to the amplifier. Its effect is that it causes whatever the impedance or whatever the resistance coming with respect to input, that should be reduced, and also due to due to addition of this, in case of an amplifier, it reduces the input impedance, as well as it also reduces the output sorry, when we have to be use this type of the product, this causes it reduces the input impedance. Okay, these things are same, right? It reduces the input impedance, this causes, and the series connection at the output increases the output resistance. These terms are double. No, both things are same. Input reduces, input resistance reduces, that is the same. Okay, when we have to be use the current shunt type of the feedback, it causes whatever the input impedance, that should be reduced, and use of the current shunt type of feedback, there should be increase in the output resistance. Okay, these are the thing happen with respect to when we have to be use the current shunt type of the feedback. Okay, these are the some of the introductory thing with respect to this type of the configuration. We have seen detail how the particular feedback should be connected with respect to the input and output. We have seen the diagram. See the diagram. Any problem on it? Please tell me. We see the diagram and then you have to understand all of the things. Okay, याच्या रिस्पेक्ट टू सगळ्या थिंग तुम्हाला डायग्राम पाहिल्यावर लक्षात येतील. ओके, याच्याबद्दल काही प्रॉब्लेम आहे का सांगा, असेल तर आपण इथंच क्लिअर करू. त्यानंतर डायग्राम, ऍक्च्युली डायग्राम मध्ये सगळं प्रॉब्लेम क्लिअर होतील. डायग्राम आपण पाहून घेऊ, त्याच्यात नाही काय लक्षात आलं तर मला सांगा. ओके, चालेल. आत्ताची इथं काय सांगायचंय, प्लीज टेल मी. डायग्राम पाहून घेऊ आपण, त्याच्यात काय प्रॉब्लेम तुम्हाला समजलं नसेल, काय होत नसेल तर मला त्यावेळेस सांगा. ओके, चालेल का? प्लीज टेल मी. All the four type have their different four diagram. See the diagram initially, how it should be connected. Whatever thing they have to be tailored, that is right or wrong, you have to see. See first, 1 minute. Voltage series feedback. See, as it is voltage series feedback, start up with the feedback, right? See, term is voltage, right? Term is voltage. How the voltage should be connected? Tell me. It should be connected. It should be collected through the series or parallel. Please tell me how the voltage should be collected. voltage I'm telling you in Marathi how the voltage should be measured, series or parallel.
Parallel.
Right, how the current should be measured,
Series.
right? So voltage series indicate that whatever the output coming, that is a voltage. Okay, so voltage should be applied to the other devices, so it should be in a parallel. Okay, so whatever the feedback coming from here, that should be in a parallel. Why? Because that is a voltage. We know that voltage should be collected from parallelly. Okay, this should be connected to the here as a parallelly. Okay, here this should be collected up to the feedback network. Okay, feedback network. Again, voltage series means whatever the output coming, that is a voltage output. Okay, that voltage output connected to the input in a series, right? That's why it should be connected to the input in a series. Okay, see in this case, see, we have applied the input. See, whatever the input applied across it, that output is coming across your output. Okay, that output we have to be collected as a voltage. Okay, voltage collected, that's why it should be indicating as a parallel. Okay, this parallelly connected to the feedback, right? Feedback. Okay, so it indicates that voltage, right? So it should be connected to the input in a series. Okay, so it should be connected in input as a series. It shows that it is a voltage series type of the feedback. Okay, see, व्होल्टेज सिरीज फीडबॅक कसा आहे लक्षात येत आहे का? व्होल्टेज सिरीज हे आउटपुट व्होल्टेज आहे पहा, आणि ते तुमच्या इनपुटशी सिरीज मध्ये कनेक्ट केलेलं आहे पहा. सिरीज मध्ये पॅरलल मध्ये जर असतं ना, काय केलं असतं आपण, हे इनपुट ऍज इट इज ठेवलं असतं, खालचा पॉईंट वरचा पॉईंट, वरच्याला पॉईंट, खालचा पॉईंटला क्लिक केला असतं. ओके, इट इंडिकेट दॅट पॅरलल. सो सिरीज अँड पॅरलल इंडिकेट दॅट when series it can indicate that whatever the input connected across your, whatever output connected across input, that should be in a series. In that case, that configuration is called as voltage series type of the feedback. In case of voltage series feedback, whatever the output coming, that is a voltage, it should be connected with respect to input in a series. That's why it is called as voltage series type of the feedback. Okay, we discusses the sum term with respect to this. In this type of the circuit, a portion of the output voltage can be applied to the input voltage in series, right? See, output connected to the input in a series. That's why it is called as voltage series type of the feedback. Okay, normally due to that, what is the effect of it? The shunt indicate, shunt and series indicate that if we have to be discuss the voltage, right? Voltage indicate that it should be in coming with respect to the parallel. It is also called as shunt. Okay, so we doesn't matter that it should be as like as shunt is only due to the, because of it is a voltage. Okay, so voltage indicate that it should be connected to the feedback as in a parallel. Okay, voltage indicate that it should be connected in a parallel to the feedback. Okay, this is nothing but a voltage. Again, this is the up to the point of the feedback. Okay, now whatever the feedback coming, that should be applied to the input, that is in a series. Okay, in a series. That's why it is called as voltage series type of the feedback. Okay, this diagram shows that in case of voltage series feedback, whatever the output coming, that is a voltage, that output is again applied to the input in a series. That's why it is called as voltage series type of the feedback. When the feedback circuit is aligned in a shunt through the output, then the output impedance will be reduced. When we have to use the voltage series type of the feedback, it causes whatever the impedance coming with respect to it, it should be reduces. Okay, means whatever the output, see, term with respect to impedance, output impedance, that should, when we have to be use the voltage series type of the feedback, it causes whatever the impedance coming across your output, that should be reduced. And due to that, whatever the value of, means when we have to use the voltage series type of the feedback, it causes whatever the output impedance, that should be reduced. Whatever the input impedance, that should be increasing. This will be happen, means when we have to use the voltage series type of the feedback, it causes output impedance should be reduced and input impedance should be increases. This will be happen only due to the voltage series type of the feedback. Okay, give me the attendance. Roll number 1. Roll number 2.
Present.
3. 4.
Present.
5.
Present.
Okay, 1 2 प्रेझेंट आहे, 3 प्रेझेंट आहे, 4
Present.
5
Present.
6
Present, sir.
7
Present, sir.
8
Present.
9 10 11
Present, sir. 10 present.
okay 12
Yes, sir.
13
Present, sir.
14
Present, sir.
15 16
Present, sir.
17 18
Yes, sir.
19 20
Present, sir.
21 22
Yes, sir.
23
Yes, sir.
24 25 26
Yes, sir.
27 27 28
Yes, sir.
29
Yes, sir.
30
Yes, sir.
31 32 33
Present, sir.
34 35
Present, sir.
36 37 38
Yes, sir.
ओके ॲब्सेंट नंबर सांगतो 1 9 11 17 19 21 24 25 27 32 34 36 37
21 present, sir.
21 present. Okay. Today 5:30 there is a test on this unregulated power supply. Okay.
Yes, sir.
Okay. Stop now.